Hello, we're doing checkpoint 4.14. They want us to use contour maps to estimate the partial of f with respect to y at the point 0, square root of 2 for the function f of xy is equal to x squared minus y squared. And they want us to compare this with the exact answer. Okay, let's take a look at our level curves. We want the level curve that contains this point. And to make sure that that's going to contain the point, we need to put this point in 0 square root of 2 into the function 0 minus square root of 2 squared. That's equal to -2. So the -2 is the c value that we want. C is equal to -2 in finding the level curve. So let's try to figure out what c is equal to -2, what that's going to look like when we put that into our function, or when we set our function equal to that. Okay, now this looks like it's going to be we're used to the hyperbolas and the ellipses and stuff to have 1 on the other side, so we can divide by -2. And if you divide by -2, the signs are going to switch. So just for convenience, let me write y squared over 2 minus x squared over 2 is equal to 1. Now the signs are opposite from each other. This is going to be hyperbola, and the y is the one that's positive, so it's hyperbola opening upward and downward, and I think that's going to be the graph. So let's graph it. And hyperbola that passes through the point 0 square root of 2, and that opens upward. Not really too concerned about the shape and asymptotes and stuff like that, but that's generally how it's going to look like. So now if we want to use level curves, this by the way has a level c equals -2. That's the level of that curve. Now if we want to move in the y direction, what we want is another point in the y direction. So maybe we can grab another point over here. We can grab square root of 2 is somewhere between 1 and 2, so we can get 2 itself, or we can get 2 square root of 2. Doesn't quite matter. Let's try to put 2 in there. And so we want to have the point 0, 2 into the function. And that is going to give us an x 0 minus 2 squared is equal to, this is going to be -4. And so we're going to consider the level curve where c is equal to -4, and that is going to give us an x squared minus y squared is equal to -4. Again, we'll divide out by that, so we'll have a 1 on the other side, so it'll be a more common looking graph for us. And if you want to put 2 squared here, that would be fine also, but we'll keep it at that. We got x squared, we got y squared over 4 minus x squared over 4 is equal to 1. So the negatives got incorporated in there, and that's why there was a switch in the terms. And this is again a hyperbola, and again opening upward. And we know now that it passes through the point 0, 2, and -2 for that matter, but we're just concerned about what's happening here. So this has a level c is equal to -4. All right. Now we're going to use these graphs to estimate the derivative of the function with respect to y at this point 0, -2. So if we draw like a little line segment, a vector from 0, -2 in the y direction, positive y direction, and let's just say we'll stop here. this will give us a good idea of what this thing might actually equal to. Okay. All right. So the way we're going to do this is imagine this happening in 3 dimensions. It's like taking a step in the y direction going north, and what's happening to your height. So it looks like we're going to go from a height of -2 to a height of -4. So that's going to be going downward. We're going to be looking at a negative value. Okay. Now, in terms of the formula, this is similar to the h approaching 0 business, but we can think about it more as f of a minus f of b divided by a minus b, or something like that. And so the partial of f with respect to y is approximately equal to, and this is without the limit, f of, let's start from 0, negative, or 0, 2. Actually, let's start from 0, positive 2. 0, 2 minus f of 0, square root of 2. So we're kind of taking the points here. F of 0, 2 is -4. F of 0, square root of 2 is going to be -2. And so that changes in the z component, and then we need to know what the change is in the y component. And there's no change in the x component, like 0 and 0. So we didn't change in the x component, we just changed in the y component. So our y changed from 2 to square root of 2. Okay. Now what we're going to have here is, in the numerator, we'll have f of 0, 2, which we figured out to be -4, and then minus -2 divided by 2 minus square root of 2. And this is going to be -4 plus 2, so that's -2 divided by 2 minus square root of 2. Okay, we will need a calculator for this, and I'm sharing my application but not my whole screen, so I'm just gonna grab my calculator and punch it in there, and I'll let you know the results. Or maybe I can just use my phone calculator. All right, so we have a 2 negative, let's try that again, -2 divided by, and then I'll open the parentheses, 2 minus the square root of 2. And with a graphing calculator, you can just punch it in that way. I got a -3.41. So we know that this is going to be a negative value, and this is what we get. All right, let's compare it to the actual answer. Let's take our function and take the derivative of that. So f of x, f of xy is going to be equal to x squared minus y squared. So f of xy equals x squared minus y squared, and f sub x, or sub y, we want the partial with respect to y, is going to give us -2y. And then we want to figure this out at the point 0, square root of y, or square root of 2, sorry. And that is going to be -2 square root of 2. And what is -2 square root of 2 equal to? Again, with my calculator, I have -2 times the square root of 2, and that gives me a -2.828. -2.828. All right. fairly close. At least they're both negative. They're hovering around -3, and it's just an approximation. So, okay, I hope that helps.